In this video, we will show you how app-based.io search settings panel in the control plane works. Search settings is arguably one of the most powerful panels with respect to setting the search relevancy. It lets you see the schema over here. You can add in any fields from your schema that you want to be searchable. For instance, let's say we want to make address field searchable. So we can add it over here. We can also, for instance, add a field. And if a field were already present, like for instance, I just added category, but assume this were present from before, we could remove it from search. Abbase also offers a use case column. The use case currently is set to search and aggregations. But we really only will be searching for address. We won't be aggregating or creating a facet from the address field. Same is true for name. So we can set the use case here. By setting the most narrow use case, you can optimize on the storage being used by App-Base. If you set a broader use case, that gives you more flexibility at the trade-off of storage. There's also an option to set the field weights. A field weight, as the name suggests, really implies that when a match happens for a given search term, it's going to prioritize the field according to its weight. So here we want to make sure that all things equal, name should have a higher weight than an address, and we can decide by what factor. For instance, I can say name should have a weight of 3 versus address having the default weight of 1. Now if this all looks good, we can review and save it. Any change that is done in the schema is going to require a reindexing, as it says here, and depending on the size of your data set, reindexing can take up to a few minutes. If you have several GBs of data, it can even take up to an hour. So once the data is reindexed, we can use the test search relevancy UI here to test this right now. And so we can search for, let's say, pizza, and we can see there are 26 results that match pizza. We'll try to understand how search works a little better. And so one of the key things to note for relevancy is the score value. The score value is higher whenever there is a higher relevancy in the result document. So we can see that when pizza occurs twice, it's going to be more relevant than when pizza only occurs once. And then when pizza does not occur as a separate word, it decreases the scoring further. So this gives you a pretty good default as far as the search experience goes. However, there are situations where you may wish to change the kind of querying experience that your end users can do. The default experience is called reactive search. This is the opinionated flavor that App-Base applies to Elasticsearch. Reactive search also stands for the name of the UI components library that we have been maintaining for the past 3 years, and is how we came up with the query type called reactive search. The second option here is query string. Query string effectively lets you, the developer, expose the query string syntax to the users. This is not desired in 95% plus scenarios, but in certain scenarios, if you're creating an expert-driven search where you want to give a lot more controls over the fields to be searched, the way you can combine the terms, you could use query string in that case. Query string is also a very strict query mode. If the user is going to make a syntax error, then it's not going to return any results. It will return an error. The third mode is the search operators mode, which is similar to the advanced search mode in Google. This can be used to provide an advanced search experience in a variety of settings. This is still more useful than query string in the sense that end users could be using this experience, but at the same time, it's not what you want as the default search experience most of the times. So we'll do a quick demo showing how search operators work. And the neat thing is, when you're making changes that do not require a reindexing, you can directly test them through search relevancy even before applying them. So that lets us be sure that the changes we make are good. So let's search for coffee. We see that coffee is found in 4 documents. And here, coffee is found as a prefix, which is why it's not highlighting, but it's still found. Now, if we search for tea, we see 11 results. So what we want to do using search operators, which we are on right now, is combine coffee and tea together. So the way we would do is we would add the plus sign, which really means that we want to make sure this search term is present in the results. And so we asked the engine to ensure that both the search terms were present, and now we got an intersection of documents where both coffee and tea were present. We can do even something even more fun. We can say, get me the places which have coffee but they don't have tea. And that gives us these two result documents where coffee is present but tea isn't. We can even say, give me, it's a negation. We can do, give me all the documents where T is not present, right? And we had 999, and we know that T had 11 results. And so if you subtract the two, you can see that there's a perfect set negation being returned by the engine. So this can be pretty useful. You can do a lot more things. You can use brackets to combine. You can also use fuzzy operators. So let's see how a fuzzy would look like. So we want to say, let's say if coffee were mistyped with an extra E, and if you would search for it, there's no results. But if a fuzzy operator in this search syntax would work like this, you would provide a tilde character followed by the number of characters you're okay with the fuzziness. Sorry, I actually picked the suggestion there. So I'll type this again. And we can see that now we got the same 4 results back. If we make this more flexible, I mean, right now nothing else is matching, but let's say if we had mistyped it like this, it matches 71 results. And the reason is now with 2 characters being fuzzy here, it could also match cafe. And you can see that in the highlight, right? It treats now cafe the same as coffee. So this gives us a lot of extra results. And so whenever you're using fuzziness, you always want to be sure about how much the tolerance should be set for it. Even if you're not using search operators and you're using the default query type, which we recommend is the way to go for majority of the use cases, you can still enable typo tolerance. And whenever you enable typo tolerance, you can pick how much tolerant do you want the search to be. There are 2 other options. One is enable synonyms and one is enable engrams. So synonyms, when enabled, allows AppBase to also search across any user-specified synonyms. User here is the developer. So that it's going to match against those synonyms as well. We will look at how synonyms work in a little bit more depth in a separate video. Enable engrams is interesting. AppBase has an opinionated approach to indexing data, and it applies all the necessary analyzers to ensure that a prefix-based search or a partial search is possible. The way a partial search works, or to be more precise, an infix search, that is, you're typing partially, but you're typing partially from the middle of the word. So I'll give you an example of this. So let's say we are, and let's go and say we have typo tolerances off, right? So we are not looking for any typos, but I'm typing coffee, but I'm typing it in a way that it's starting from like FEE. This is not all that common, but because we have engrams enabled, it can actually pick infix matches as well. But engrams comes at a cost of adding more storage to the index. And depending on the kind of data you have, this can have an impact from 10% to 30% in the storage. And since this impact is pretty significant, we provide it as an option. If somebody were to disable infix search, they could make that trade-off and not incur the extra storage penalty. Even if you disable engrams, the prefix search from the start of any word would still work. We think that's a very important experience, and we enable it by default and don't provide it as a choice. But this is an optional experience that a user can decide whether to choose or not. Now, a very important feature of the search settings panel here is if you were to deploy your front end where you don't specify the fields or the weights in your code, then the control plane is going to set them. And this gives a developer an amazing ability to deploy their changes of search relevancy in real time. So to do this, first of all, let me go and pick search operators again and effectively just save this. And I'll open this demo of the front-end application that we have, which is using Reactive Search. This application was built as part of the Reactive Search tutorial series. In case you're interested in building this from scratch, check out the link in the description. But over here, what's happening is we are setting the data field right now from the code base, and it's set to name. And it's also set to the default query type, which is reactive search and not search operators. And while you can specify these options from within the code, specifying them here would imply, one, that you're exposing your business logic to your end users, and two, you need to redeploy your code to make changes. So what we're going to do is we're going to get rid of this data field completely, and we are going to set a prop called enable app base as part of reactive base. We'll save the setting. We'll reload this page to be sure that it's now using the new setting. And we can check out and get the same experience that we were seeing in the test relevancy UI. And we can try to find a term, search for coffee and tea together, and we get coffee and tea together. So it basically took in the field names to search for from the control plane. It took in the query type as well from here, and it took in the field weights as well from here. To kind of really be sure and to kind of test this in a very different way, what we can do is, let's say, get rid of the name field from our search. So once this re-indexing is complete, it should no longer find results when we search for coffee and tea, unless maybe an address has those results. But at the very least, we should see something different than what we are seeing here. So we'll try this out. So we'll search for coffee this time, and we can see no results are found. So this gives you an amazing degree of flexibility to set your search relevancy, deploy them from the control plane without having to ever change any line of code. And so you can cleanly separate out the development part of your search experience from the relevancy part of your search experience, which is very powerful and gives a lot of control to the entire team operating search relevancy.